Since we don't have standard electrochemical cells, we will need to use the Nernst equation to calculate the cell potential. The Nernst equation is E cell equals standard E cell minus 0.0257 over N times the natural log of Q. Before we can use the Nernst equation, we need to calculate the standard cell potential. So we have a cell made up of a zinc half and a chromium half. And so let's write reduction half reactions for each half. So zinc 2 plus gains 2 electrons, and chromium 3 plus gains 3 electrons. And the problem gives us the standard reduction potential for each half. So for zinc, negative 0.76 volts, and for chromium, negative 0.34 volts. Since chromium is the most positive reduction potential, it will stay at the cathode and undergo reduction, while the zinc half will flip and occur at the anode. So let's write the zinc reaction as an oxidation. So this time we have zinc losing 2 electrons, and instead of a reduction potential, we would have what we could call an oxidation potential. We can calculate the standard cell potential by adding the reduction and oxidation. So 0.42 volts. And we will need the overall reaction so we know how many electrons are transferred. So in order to balance the electrons, we would need to multiply the chromium half by 2 and the zinc half by 3. And our balanced reaction will be 2Cr3 plus 3 zinc to give 2 chromium and 3 zinc 2 plus. And notice that we would have a total of 6 electrons transferred. Now we're ready to use the Nernst equation. So let's plug in what we know. We have cell potential equal to the standard cell potential, 0.42 volts, minus 0.0257 divided by N, which is 6, natural log of Q. Q is the reaction quotient, so we can go ahead and put an expression in for Q. We know that Q will be the concentration of zinc 2 plus cubed divided by the concentration of chromium 3 plus squared. Remember that we don't include solids in our reaction quotient, and we've got zinc metal and chromium metal. I will rewrite our equation and plug in our concentrations given in the problem. So zinc concentration is 8.5 times 10 to the minus 3. Remember that that must be cubed. And our chromium concentration is 1.0 times 10 to the minus 2 squared. Doing the math, we get E cell equal to 0.44 volts. Delta G is related to the cell potential through the following equation, negative N F E cell. And we just have to plug in some values here. Delta G equals negative, we know that N is 6, F is Faraday's constant, 96,500 joules per volt times mole of electron. And then multiply by the cell potential that we calculated. So delta G is equal to negative 254,760 joules. And let's put it in kilojoules because most often that's how delta G is reported. So we get negative 255 kilojoules.